Hello dear students. Today we are going to talk about matrices and linear equations. Let us choose 4 students from the Mathematics 1 course which you took last semester. Call them Kaan, Aslı, Ayaz and Melis. Let us denote the lectures they had taken in the last semester. Let them be Mathematics 1, Introduction to Law, Information Technologies and Introduction to Business. The row the name corresponds to and the lecture, the column of the lecture will be denoted by 1 if the student had passed this lecture, and it will be denoted by 0 if the student had failed this lecture. It means that Kaan has passed all his lectures, where Aslı passed only Introduction to Law and Introduction to Business, where Melis only failed from Introduction to Business. So now if we remove all these lines, names and everything from this table, and if we only keep the numbers, we may denote this table as a rectangular array of objects. In this case numbers. So we have 1 1 1 1 0 1 0 1 1 0 0 1 and 1 1 1 0. Now we know what these numbers denote, right? So let's call this rectangular array of numbers as A. This A will be called a matrix. And since we have, there are 4 rows in this matrix, and this is the second row, and there are 1, 2, 3, 4 columns in this matrix, so this is the third column. Now we are choosing the second row and the third column, which actually corresponds to, I can't remember who this was. Let's go back. It's Aslı and Information Technologies, and if we go back here, A23 denotes Aslı failing the Informational Technologies course. So we label this element 0 as A23. In this case, in this notation, 2 means the row, the number of row, and 3 means the number of column, and A is just an element of the matrix A. So a matrix which has m rows and n columns is denoted by this rectangular array of numbers A11, A12, A1n, A21, A22, A2n, and so on and so forth. So the last row is A1m, AM2, and AMN. So this is called an m by n matrix. A square matrix is a matrix where the number of rows is equal to the number of columns. So in this case we have n rows, right? We have n rows and we have n columns. So the size of this matrix is n by n. The diagonal, the main diagonal it's called, the main diagonal is the entries on the diagonal of this matrix. So they are the elements A, I. So the index of A will be the same I for the row and the column number. So A11, A22, A33, and so on and so forth up to ANN will denote the main diagonal entries of a matrix A, where A is a square matrix. We may have just a single row, and then we are going to call our matrix a row matrix. Very similarly, if we have only a single column, then we are going to call this matrix a column matrix. We have only one single column, which we are going to encounter in a few minutes. The identity matrix. Okay, if the main diagonal of a square matrix A is all ones and all the remaining entries of the matrix is 0, such a matrix will be called an identity matrix. Note that an identity matrix, at least in our course, must be square. How about the 0 matrix? Well, it's quite straightforward. All the entries must be 0. If all the entries of a matrix A are 0, then we call this matrix A the 0 matrix. Now, some basic operation on matrices. We know how to sum numbers. We know how to subtract numbers. How about summing and subtracting and multiplying matrices? The sum of matrices A and B is defined as the sum of the corresponding entries of the matrix A and of the matrix B. So we are just adding the same components of the matrix A with the matrix B. Aij plus Bij. So if I'm taking the second row, third column of the matrix A and adding it with B, I must take the second row, third column of the matrix B. As an example, let's take the matrix A, which has 3 rows, 2 columns. So B must have the same size, so it must have 3 rows and 2 columns. And if I add them, I add 2 and minus 1, 1 and 2, 0 and 5, minus 1 and 3, 3 and 1, and minus 4 and 0. When I do that, I end up with the final matrix 1, 3, 5, 2, 4, minus 4. I can multiply a matrix by a scalar, which is quite straightforward, and it's defined as the multiplication of each entry of the matrix A by the same constant C. So when you multiply a matrix by a constant C, you have to multiply every single one of the entries by the constant C. I'm given again this matrix A, which is 2, 1, 0, minus 1, 3, and minus 4, and I multiply. I'm trying to find the 3 times A, 3 multiples of A, so to speak. So what do I need to do? Just need to multiply every single entry, which is gonna give me 6, 3, 0, minus 3, and 9, minus 12. So this is 3 times A. Okay, now comes the most difficult, probably the most difficult operation on matrices, the multiplication of 2 matrices, A and B. First things first, in order to be able to multiply a matrix A by a matrix B, the number of columns of A must be the same as the number of rows of B. So as you see from this A, M, the number of columns of A is M, and the number of rows of B is also M. This means that I can multiply them. So how do I multiply? Let's just assume that I'm just multiplying it out and I'm getting a matrix called C. So the ijth entry of C. How can I find the first entry of the first row, first column of this matrix C? I have to multiply the first row by the first row of A by the first column of B. So if I do that, A11, B11, A12, B21, A13, B31, and if I continue like this, I get C11. How do I find let's say C12? Then I have to start with, again, this one, but first row, but then the second column of B. If I want C13, I have to start with the first row of A, but this time the third column of B. And I can continue this process to find the whole of the matrix C. So Cij is given as AI1 plus B1j plus AI2 plus B2j, and so on and so forth, as you can see on the screen. Since we are going to deal with matrices which are 2 by 2 or at most 3 by 3, multiplication is not going to be a problem, and let us multiply these 2 matrices. Just let's say the result is again a matrix called C, and the first entry of this C, as we said, is the multiplication of the first row by the first column of B. First row of A, first column of B. So let's do it. 1 times minus 1 plus 0 times 4 is minus 1. For C12, I need 1 times 2 plus 0 times 3, which is 2. And if I continue like this, the matrix I find will be minus 1, 2, 5, and 12. Since I have 2 square matrices, it turns out that the number of columns of B is the same as the number of rows of A. It means that I can also multiply B and A. So BA, if I do that, is given by 5, 4, 13, and 6. So you all need to do just carry out the calculation on your own, please, and you'll find that it is 5, 4, 13, 6, which tells us a very interesting fact about matrix multiplication, that it is not commutative. So A times B is not B times A in general. So how can we employ matrices in our daily lives? For example, assume that Aslı and Kaan, who are students at our university, decided to have lunch together. They go to the canteen and Kaan buys 2 toasts and 1 chai for 7 liras. And Aslı buys 1 toast and 1 chai for 4 liras. How do we find out the price of a toast and price of a tea? So the price of a toast, let's denote it by X, and the price of tea, let us denote it by Y. So the first line of these two equations, 2x plus y, corresponds to what Kaan bought and how much he paid. So it's 2x plus y, and what Aslı bought and what she paid corresponds to x plus y equals 4. So we have two equations. This is a system of linear equations. We have two equations and we have two unknowns, x and y. So we'd like to solve this. What we do is we multiply the second equation by a -1 and add two equations. When we add two equations, we get rid of y. We have x equals 3, and if we insert this x equals 3 in the first equation, y becomes 1. So the price of a toast is 3 liras and the price of a tea is 1 lira. If we draw these two lines, if we interpret this two linear equations in terms of their geometric meaning, we see that the first one denotes a line and the second one also denotes a line. And if we put these two lines on the plane, we see that they intersect at one point, which is x equals 3 and y equals 1, which is actually the solution of this linear system of equations. Now, we can write this system of equations in terms of matrices, and we can, by doing this, see how the matrices are related to linear equations. The coefficients in these two equations of the unknowns x and y are given by 2, 1, 1, 1. Let us denote this rectangular array as a matrix A. The constants x and the unknowns x and y, we can write it as a column matrix, which we defined already. So if I multiply the matrix, the coefficient matrix A, by the unknown matrix, column matrix B, I get the left-hand side of these linear equations. And what's the right-hand side? It is another column matrix, which is given by B equals 7, 4. So all I need to do is, write this linear system of equations in terms of their matrix notation. So I get 2, 1, 1, 1 times xy equals 7, 4, or in short, A times x equals B. As I said, A corresponds to the coefficient matrix of the system of equations. Capital X denotes the unknown matrix, in this case a column matrix, and B denotes a constant matrix, which is the right-hand side of our linear equations. Now, geometric interpretations of two linear equations in two unknowns. Let us be given ax plus by equals z and cx plus dy equals f. I'd like to find a, b, e, c, d, f are constants, x and y are the unknowns, and what I'd like to find are the values of x and y. We have three possible cases, and geometrically it's very, very simple to find out what these three possible cases are. The first one is these two lines, since they correspond to lines, these two lines are parallel. So they are lines like this, they have no common points. So, well, we are going to talk about it in a minute. There's only, these lines may intersect at only one point. And this will tell us there will be only one x and y. And these lines, these parallel lines, may be on each other. Mathematically, we say they coincide with each other. So, in the first case, there is no solution, which means that since these lines are parallel, there are no x and y which simultaneously satisfy these two equations. In the second case, since they intersect at one single point, we'll have only one single solution, and if they coincide, it means that every x and y will satisfy both of these equations simultaneously. Yeah, okay, let's give some examples. 2x minus y equals 2, 2x minus y equals -2. This means that we have two lines which are denoted by blue and red lines here. They have no common point, so there's no solution. And we can also, since the left-hand sides are equal, we can equate 2 to -2, which is not the case. It means that there's no solution. Let's consider this system, x plus 2y equals 0, x minus 2y equals minus 4, and if we denote these lines on the plane, we'll see that they are going to intersect at one single point, and this single point is x equals minus 2 and y equals 1. So there's only one single solution. Now this is funny. X minus 3y is 1, 3x minus 9y is 3, which seems the two equations different, which is not the case. If you multiply the first equation by 3, you completely get the second equation. It's just the same thing. And if you draw these two lines, you'll see that they are on each other. How many x and y's we have? Infinitely many. Every x and y satisfy both the first and the second equations. So I think that's all for the matrices and linear equations, and we have learned that linear equations, which we are more interested in actually, can be denoted by matrices, and matrices are in a sense just a shorthand to simplify many of the calculations we are going to encounter. Now it's best if you go to your book and read it very carefully with all the details which I skipped in this video, and try to solve all the questions. Until next time, see you.